So, you've probably played around with an AI, right? Asked it to write an email, maybe even a funny song, and it feels pretty smart. But today, we're going to talk about the ghost in that machine. We're asking a much bigger question. How do we build an AI that doesn't just pretend to understand, but actually truly gets it? And this quote just nails it. Our most advanced AIs, they can spit out poetry, they can write code, but at their core, they're just trapped in this giant web of statistics. They're incredible mimics. They can manipulate words and symbols, but they have absolutely no genuine grasp of what any of it means. And that isn't just some small technical glitch. It's a huge crisis. It means they can tell you what something is, but they have no idea how or why. And this gets to the heart of what we're calling AI's meaning crisis. It's almost like a throwback to the old philosopher Immanuel Kant, who was tearing his hair out trying to figure out how we connect the stuff we see with the concepts in our head. Well, AI is stuck right in that same gap, and it's basically split the entire field right down the middle. So you've got these two very different paths. On one side, you have deep learning. Yeah, it's super powerful, it can find patterns in almost anything, but its knowledge is buried inside millions of calculations. It's a total black box. We can't see how it thinks. And on the other side, you have the old school symbolic AI. Now, this stuff is transparent, it's logical, but it's also incredibly brittle. Someone has to hand code all the rules. The second you show it something it hasn't seen before, it just breaks. And worse, its symbols, the words it uses, they aren't connected to anything real. They're just floating, which leads to this famous symbol grounding problem.
Okay, so that brings us to the really big question, right? If our best and brightest technology is completely stuck in this conceptual trap, how in the world did we, as squishy biological creatures, ever figure this out? The answer, as it turns out, might just be the key to a totally new kind of AI. And the inspiration for this whole new way of thinking, it comes from the amazing work of a developmental psychologist named Jean Piaget, who spent his life figuring out exactly how kids build their own understanding of the world from scratch.
Piaget's model it's so simple and so powerful. Imagine a little kid. They have a mental model, a concept. Let's call it a doggy schema. Now they see a cat for the first time. What do? First, they try to assimilate it. It has 4 legs, it's furry, it must be a doggy. But then someone says, no, sweetie, that's a kitty. And this is where the magic happens. Accommodation. The child either updates their doggy schema, maybe doggies bark, or they create a whole new one for kitty. And this constant cycle, this back and forth of assimilating and accommodating to find a balance, well, that's the engine of learning. That's how we grow.
And here's the real kicker. This is the computational blueprint that's been hiding in plain sight this whole time. Piaget's learning cycle? It's not just a nice metaphor. It's a direct one-to-one parallel with a machine learning process called expectation maximization, or EM. The E step, or expectation, is literally assimilation, trying to fit new data into the models you already have. And the M step, maximization, is accommodation, changing your models when the data just doesn't fit. This is it. This is how we can actually teach an AI to learn like a child. Which brings us to the big breakthrough. See, to solve this meaning crisis, we don't need a better dictionary for our AI. We need a totally new kind of sign, a new kind of symbol, one that is born from the world, not just assigned to it. And this new kind of sign is at the heart of an idea called curve ontology. Now stick with me here. The idea is that concepts aren't static labels like the word frustration. Instead, a concept is a characteristic shape of change over time, a curve, that the AI discovers all by itself straight from the data. It's a huge shift from seeing the world as a collection of static things to seeing it as a beautiful symphony of processes.
And here it is. This is the simple idea that unlocks the whole puzzle. With a curve, the sign, the shape itself, and what it signifies, the real-world process, they become the same thing. A rising slope is something getting more intense. A dip is a decrease. The meaning isn't just arbitrarily attached to a symbol anymore. The meaning is the shape. The sign is literally born from the data of the world.
You want to see this in action? There was this incredible experiment. An AI was hooked up to gamers' physiological data, heart rate, sweat, you name it, while they played a really tough video game. Without any help, without any labels,
the AI started noticing patterns. It found 3 distinct ways players responded to failing over and over. And one of them was this very specific temporal shape, a curve that perfectly captured what we would call frustration. The AI didn't learn the word frustration. It discovered the iconic shape of it directly from reality. So, okay, that's an amazing idea. But how do you actually take that philosophy and build a real intelligent system with it? Well, let's take a look under the hood of something called the Kronos Agent, an AI architecture built on this exact idea. The Kronos Agent architecture is just so elegant because it brings together the best of both AI worlds. At the very bottom, you have a curve discovery engine. Think of this as the learning child, just digging through raw data, finding those meaningful shapes, those curves. Then, sitting on top of that, you have a temporal reasoning layer. It takes those curves the system discovered, like our frustration curve, and treats them as brand new grounded symbols. It can then reason about how one process might lead to another. So it's a system that can both perceive the world and actually think about it. Now, the engine that makes all this possible is a technology called temporal graph RAG. And the best way to think about this is like a living memory. Instead of storing a bunch of separate, isolated facts, it builds a dynamic map, a graph of how events and relationships change and evolve over time. It doesn't just know that A is connected to B, it knows how and when that connection happened and how it's probably going to change in the future. And look, this isn't just some theory on a whiteboard. It actually works. Frameworks that are built on these exact principles have shown an 18.5% jump in accuracy on really complex temporal tasks. That means they are quantifiably, measurably better at understanding how things actually unfold in the real world. But being accurate is one thing. Being accurate and fast, well, that's the real game changer. The same system achieved a 90% reduction in latency. I mean, a 90% speed up. That's what takes this from a cool academic project to a tool that can deliver real-time, dynamic insights right when you need them most. So what can you actually do with an AI that gets that the world is a process, that it's all about change and becoming? The applications here, they're truly transformational. Well, an AI that understands change just sees the world in a totally new way. In a factory, it doesn't just see a machine. It sees the degradation curve of a part that's about to fail, and it can predict that failure before it happens. For a scientist, it can sift through mountains of climate or medical data and spot these hidden temporal patterns that might lead to a brand new hypothesis. A robot can finally learn the feeling of pushing a heavy box by understanding its force feedback curve. It could even understand us better by recognizing the subtle shape of confused hesitation when we're interacting with a computer. And that manufacturing example, it's not a what if. This is already happening. Companies using these temporal systems for predictive maintenance have documented a 20% reduction in unplanned downtime. For any big factory or operation, that's not just a nice number. That's millions and millions of dollars saved by an AI that truly understands the process of things wearing out. So where does all this leave us? I mean, this is clearly about more than just building a smarter machine. We are looking at a fundamentally new vision for what cognition itself could be. What this all promises is a new kind of AI. An AI that's finally interpretable because every single concept it learns can be visualized. It can be drawn as a curve. It would be continuously adaptive, evolving its understanding with every new experience, just like we do. Its knowledge would be robustly grounded in real, perceivable patterns, finally solving that old symbol grounding problem. And most importantly, it would be temporally native, built from the ground up to understand a world that is defined by constant change. And this leaves us with a pretty profound question to think about. By building an intelligence that is grounded in the flow of reality itself, an AI that sees the world not as a collection of static facts, but as a constant dynamic process of becoming, are we just building a better, more efficient tool? Or are we taking the first real step towards creating an intelligence that can genuinely share in and understand our world right alongside us?